Our last topic in chapter 2 in the textbook is about the climate history of our planet. And we're going to break this down to two pieces. First of all, what do we know about past climate? And secondly, how do we know that? And we'll talk about that part at the end. So we're going to start out with what do we know? And why are we talking about this? Because it's important to have a sense for how wide the variation of climate has been in the past for us to appreciate what kind of climate changes could happen in the future. So we know there have been ice ages, so it's reasonable to suppose it might get cold in the future. But in this day and age, when we're thinking about climate change, it's probably useful to figure out how warm has it been as an indicator to how warm might it be in the future. So we're going to start at the very, very beginning, because if we want to talk about the atmosphere, at some point in time you have to go back to when the Earth itself formed. And I don't think it's a terribly bad idea to know where the Earth came from, because that helps you contextualize everything. So where did Earth come from? And for that matter, where does any planet come from? How does a planet form? So rather than me explaining it, why not have Stephen Hawking himself explain it to you in a short video? And here's the link. It's on YouTube. It's a short video. It's written by Stephen Hawking, not narrated by Stephen Hawking. So here it is. I'll just get you started. Here's the URL. Get you started.
Our solar system, the place we call home, lies about 26,000 light years from the center of our galaxy, the Milky Way.
Alright, so what you will see from this is that out there in the universe there is a bunch of what is called interstellar gas, and there's also a bunch of dust, and by various mechanisms that can all form a blob which rotates because of gravity, and gradually those bits and pieces of dust coalesce to form small rocks which bump into each other to form bigger rocks, and eventually you have a solar system with a planet or a series of planets going around in orbit around the sun. So that'll give you an idea of where the solid Earth itself came from. And when did this happen? The current thinking is about 4.5 billion years ago. And I want you to notice this notation here, BYA. Let's bring up the pen. BYA, that is our notation for billion years ago. And you'll see things like that quite frequently when we're referring to ancient climates. You might see MYA for million years ago. So the Earth formed about 4.5 billion years ago. And how does that relate to the universe? The universe is about 13.8 billion years old. So the universe was around for quite some time before the sun and its planets formed. Alright, so now we know where the solid planet came from. What about the atmosphere itself? So initially you have this very hot liquid mass, but gradually it loses energy and begins to cool down, and in the process a crust begins to form, and we have that kind of situation now. We have a liquid core and a crust on the outside of it. During this process, the various heavier elements that were around at the time sunk, because they're heavy, down towards the core of the planet. And I think the core of the planet is iron and nickel, so those are heavier elements. And that leaves the lighter elements to rise up to the region of the crust. So the lightest elements are helium and hydrogen. Helium, hydrogen, and the other lighter elements rise during the cooling process. The very lightest elements, helium and hydrogen outgas from the planet. Outgassing simply means that those elements leave the solid planet itself and outgas into space or into the atmosphere. The helium and the hydrogen got lost to outer space. They're so light that they can develop escape velocities and escape from the gravitational force of the planet. And so what's left over are things that will allow for carbon dioxide and water to remain. And once you've got water in an embryonic atmosphere, you have the possibility, if it's not too hot, of that water condensing and then raining out and then collecting into puddles and then oceans and getting the hydrological cycle underway. So all of this happened sometime between the beginning and about the first billion years of Earth's formation, so that by about 3.8 billion years ago there were primitive oceans and some kind of an atmosphere had formed. Now, the earliest atmosphere didn't contain any oxygen, and therefore nothing that we would recognize as life would have existed. So where did that come from? The first oxygen came from very primitive organisms in the oceans that did the process of photosynthesis. In other words, taking in sunlight from the sun, taking in carbon dioxide that we know is in the atmosphere, and emitting oxygen as a byproduct. This started in the oceans, we think between 3 and 3.8 billion years ago. And then initially the oxygen was locked up into rock formations in a mechanism that's explained for you in the textbook. But eventually that became saturated, and so oxygen atoms and molecules were left to begin collecting in the atmosphere. So then you had the buildup of atmospheric oxygen. And I've given you a link here to another website that's got some useful information, Evolution of the Atmosphere. And that includes a discussion here of formation of oxygen in the atmosphere. And as you can see from the pictures, it's not just telling you what we know, but there's also some evidence to prove it. So we have oxygen building up in the atmosphere, and eventually all you need is for those oxygen atoms to bump into each other and congeal, and then you have ozone, O3. And so once ozone formed, you had then a shield from the ultraviolet radiation, a shield allowing life to crawl out of the oceans and onto the land. So far we're up to roughly a billion years ago, starting at 4.8 billion years ago.